Hi everyone, the next topic in our unit is multiplying and dividing rational expressions. So the name of the game with these is to always try to factor first if you can. You'll see in the first couple examples factoring just isn't possible, so that's obviously if you can't do it, you can't do it, but you always want to try to do that first. So let's look at number 1. So you have 3 over x times 4 over x squared. So you are literally just multiplying two fractions together. So how do you multiply fractions? You multiply across, okay? Remember, another trick when you're multiplying fractions is you can cross cancel, and I'll demonstrate that trick in another problem because there's nothing to really show here. So all I do is multiply across. 3 times 4 is 12, and x to the first times x squared, I add the exponents, x cubed. That's your answer. You cannot simplify 12 and x cubed, so that's your answer. Number 2, again, you look to try to factor. There's nothing you can factor, okay? You cannot cross off this x with this x, or this x here with the x in the denominator. Why? Because this x here is part of the quantity, the binomial x plus 4. This x here is part of the x minus 3, and this is part of the x minus 2. You can only simplify, meaning cross out, if terms are being multiplied together, like 12x. Okay, those could be separated. All right, so there's nothing to cancel, so I just multiply across. X times x minus 3. I'm just going to leave it like that. And I encourage you to leave it like that because usually in other problems it's easier to see if terms cancel. And then I have this. So that is a fine answer. Nothing cancels. You don't just have a regular x down here to cancel x minus 3. You'd have to have the quantity x minus 3 in the denominator to cancel. So there is your answer. I know that's strange. You're like, what was the point of that? It's just multiplying the two fractions together to get 1. If you wanted to distribute and then FOIL the denominator, that wouldn't be wrong. It's just extra work. Number 3. So again, remember, like I said before, if you can factor, you're going to want to factor. 2x plus 1, nothing factors there. And I'm going to also show you another trick at the same time. Look, you have a 3 in the bottom. Remember, this is 6 times x, and a 6 in the top. So I can cross or reduce those each by 3, because 3 goes into 3 and 3 goes into 6. So 3 goes into itself once, 3 goes into 6 twice. So now in the denominator, I have a 1. I'm still multiplying because I'm going to show you the factoring, what I have to do here to factor. And then in your numerator, you have a 2 times x, a 2x. Now here's the factoring piece, 4x squared minus 1. This is the difference of two perfect squares. So guys, back in the factoring unit when I said, if we don't know how to factor, we're going to have a hard time in this class, and you should have seen that. This is the multiple times we've seen factoring since the factoring unit. You got to know how to factor. So it factors into 2x plus 1, 2x minus 1. Now remember, for items to cancel, when you're multiplying, if you have a term in the numerator of one and the denominator of the other one, they will cancel out. So let me save myself some writing. I have a 2x plus 1 in the top and a 2x plus 1 in the bottom. Those cancel out to 1. If you want to write the 1, go ahead. So I have a 1 times 2x. So my numerator is 2x. And then I have a 1 times 2x minus 1. Now, people usually want to be like, oh yeah, I can cancel these two x's. No, you cannot, because the denominator is the quantity. It's the binomial 2x minus 1. You cannot cross those out. That is your answer. Number 4. You might be like, oh, 8x and 8x, let me cross those out. No, the 8x here is part of the binomial, okay? You can't cross these out because this is a monomial. This x is part of a binomial, so you cannot cross those out there. So this is another case where I can factor. How do I know? Because just looking at these, I'm like, oh, I could factor x squared minus 4. And I don't know why this thing just can't stay focused. So let me do what I need to do here. So the first fraction, can't do anything. So I rewrite that. The second fraction, the numerator, what can you take out of a negative 8x and a negative 16? You might say x, or excuse me, 8, but I'm going to take out a negative 8 because they're both negatives. And I feel like if I do that, it might look better and be easier to work with. So if I take a negative 8 out of a negative 8x, you're left with x, and this is going to be a plus 2 that you're left with. Okay? X squared minus 4, once again, difference of perfect squares. That factors into x plus 2, x minus 2. All right, so to save yourself some writing before you go and just multiply straight across, let's see items that we can cancel. We have the quantity x plus 2 and x plus 2. Again, it doesn't matter if it's, some people always ask, well, does it have to be on the top of one and the bottom of the other to cross out? No, it's the numerator and denominator have to be the same for it to cancel. It doesn't matter which fraction it's part of. So those two cross out. Maybe I should color code this. Okay. And then you have quantity x minus 2 and x minus 2. Those cross out. Then, some people might not see it, so I might just actually write what we have. So what's left in your numerator? You have a negative 8. What's left in the denominator? An 8x. Okay, you can actually simplify this. 8 over 8, that's 1. So what's left in your numerator? A negative 1. And what's left in the denominator? X. Those cross out. You could have done that back there, but I was just showing people here what happened. That's your answer, negative 1 over x. Okay, number 5. Again, you want to try to factor where you can. A hint for this one is I suggest anytime you're multiplying a fraction, okay, times just a polynomial of some sort that isn't in fraction form, to always write it over 1 to help you stay organized to what is the numerator and what's the denominator. So 3x plus 2, we can't factor out a GCF, so we leave that. But what can you take out of a 2x and a 4? Hopefully you're going to tell me a 2, and you're left with x plus 2. So now we go to the next numerator. Again, this isn't so bad. Think about some of the crazy fraction polynomials you had to factor in our factoring unit. You're looking for factors of 6 that add to 5. Hopefully you're going to tell me x plus 2 and x plus 3. Then I'm going to keep that 1 there just to know what's what. So again, let's see what cancels. We have an x plus 2 in the bottom and an x plus 2 on the top. Those go away. And looks like that's it. So I'm going to leave this as quantity, use your parentheses, 3x plus 2 times x plus 3 in your numerator. And then in your denominator, it's just 2 times 1, which is 2. No, those 2's do not cancel. Okay, this 2 is part of the binomial 3x plus 2. So do be careful. That is your answer. Last one for the multiplication, then I'll start a new video for the division one to break it up a little bit. So again, we have just a regular binomial times a rational rational expression here. So that first one you can't really factor anything, so I'm going to just write it as is. 4m plus 8. You can factor out a 4, and you're left with m plus 2. M squared minus 1, that factors into m plus 1, m minus 1, because it's the difference of perfect squares again. So let's see what cancels out. You got an m minus 1 and an m minus 1. Those cross out. And nothing else. So numerator is a 4 times quantity m plus 2. Denominator 1 times quantity m plus 1 is just m plus 1. Again, those m's do not cancel out because they are part of binomials.